This video is part 4 of a 5-part series on automotive vibration analyzers. In this episode, we will cover the PicoScope NVH diagnostic kit for General Motors dealerships, part number CH-51450. Now, even though this says GM on it, it actually could be used on other vehicles, and I'll explain that a little bit later. Inside of this kit, we have a 4-channel automotive PicoScope. We have 4 scope channels here. We're going to be using channel B here for the vibration interface, the NVH interface box that comes in this kit. And the PicoScope, if you're familiar with them, is a USB interface module to a laptop computer running Microsoft Windows. So to diagnose vibrations using the PicoScope NVH kit, we need the appropriate PicoScope oscilloscope interface here, and there's several of those different models, 2-channel, 4-channel, that are supported, but this particular one, I think it's a 4424, comes in this kit. It has a maximum of plus or minus 100 volts peak, so not only can this be used as a vibration diagnostic tool, but this can be used as a 4-channel oscilloscope for electrical diagnosis. So it's a very cool setup. So we're going to need the PicoScope interface. I'll set that over here. We'll need the NVH interface, and then also we have a vibration sensor, an accelerometer, and we've got a washer stuck to the end of that to keep the magnet strong. I'll leave that on there for now. The magnet screws on to the end of the sensor, and it has arrows on it, as you can maybe able to see there, indicating up and down. And so according to Pico, they want you to mount this sensor to where it's either pointing up or down, wherever you've got it mounted magnetically. We'll do some experiments and see if it really matters if it's up or down for vibration diagnosis. I'm not sure that it does. I'm not sure I believe that. I think the frequency will still be picked up for the vibration. Possibly the amplitude will be different, but we'll find out. I've got a 2013 Camaro ZL1 over here that I've installed some vibration bugs on the vehicle, and we're going to take this over and try it out, and we'll try the sensor in a few different positions and see if it makes any difference. Okay, so the vibration sensor is going to connect to the interface box, and then the interface box connects to the oscilloscope interface, and then the oscilloscope connects to a laptop. So for just regular vibration diagnosis, these are some of the parts we need. And then inside of this lid, it swings open, and there's some more parts in this diagnostic kit. We have a USB cable that we'll need for the PicoScope interface, USB, and then it has 2 long scope leads in it, with the same connector on either end, and this is to connect the PicoScope to the NVH interface. And so there's 2 of those. We only need 1 for vibration diagnosis. The other one, in this upper part of the kit, it has an optical sensor interface, and it has an optical sensor right here with a magnetic base mount, and this is used for driveline vibration, or I'm sorry, balancing drive lines. and that's what this other cable is for, is to connect to the interface for the optical sensor. But for now, we're going to pass on the propeller shaft vibration correction and balancing, and I will probably do a separate video on that. I still need to do a video for the balancing prop shafts with the EVA, but maybe I'll do both in the same. No, I'll do two separate videos. Anyway, so for what we need to diagnose vibrations on a car in this kit, once again, we've got to have, and let me bring it over here, a laptop computer running Windows, and for the General Motors version of this, there's special General Motors software that you can download from the GM Dealer Solutions website, but you have to have a GM login to be able to do that. I told you earlier that this kit could work on other vehicles, and PicoScope has some generic software. It is called Pico Automotive diagnostic software. If you go to their website, picoauto.com, you can download the software for free, and then even though this says GM, the same setup would work on another vehicle. Okay, so to get this working, we need the laptop. We need to have 2 USB ports at bare minimum. So we're going to take the USB cable that came with the kit. We're going to plug it in to the PicoScope scope interface box here. So I'll plug that in to the laptop, and it has a driver that comes with the Pico software to enable the computer to read from the oscilloscope. And then we'll take our scope lead here and we'll attach it to channel B of the 4-channel scope, or channel B of a 2-channel scope. And then we will attach that to the NVH interface. And then we'll take the vibration sensor, and it's keyed, so it has to plug in one way only. We'll plug that in to the NVH interface, and it has a threaded fitting to hold it in place. When you get that plugged in and it's operating properly, there's a LED on the end here that'll blink periodically to let you know that the NVH interface box is working. If you don't see that blinking, there's an internal battery in here, and you'll take these screws out and replace that battery. Okay, so now this is the vibration analyzer, and in the first 3 episodes of this 5-part series on vibration analyzers, we looked at a Briggs & Stratton cyrometer, we looked at the Fram resonant reed tachometer, we looked at the electronic vibration analyzer in the 4 different versions of that. All of those do, well, this setup here from PicoScope does what all of those do. It measures vibration frequencies and amplitudes. So this is a much more sensitive sensor than the EVA had. It's much more sensitive than the reed tachometer or the cyrometer. I really like this sensor. It's got a very strong magnet on it though, so whenever you stick it to something on the car, make sure you're hanging on to the housing here when you take it off rather than pulling on the cable, because I'm sure over time that's going to cause the cable to break loose. Okay, so that's the vibration analyzer portion of the PicoScope kit, but that's not all. If you recall from the electronic vibration analyzer episode that I did, I told you that we needed vibration frequency and amplitude, but we also need engine RPM. And so what Pico has done is what I think is a very smart thing to do. They have configured their software to work with the J2534 data link connector interface. It's a kind of a generic interface to communicate with onboard engine control modules. And for General Motors, the interface that GM uses is called the MDI, the Multiple Diagnostic Interface. And the MDI just simply has a long, skinny USB cable that I'm going to plug into the laptop. And then on the other end of the MDI, we have a 16-pin data link connector, and we're going to plug that into the car. And the PicoScope software will automatically communicate with the car, pull the VIN number, decide what engine it is and how to communicate with it, and read the engine RPM automatically. Now the beauty of this is we've got the engine RPM, we've got the vibration frequency, and if you recall from the Vibrate software demonstration I showed you in the second episode, the last half of the second episode, those are the two parameters we need to nail down or narrow down the group of rotating parts on the car that is responsible for the vibration that you're trying to diagnose. So I think they've done a really good job. In episode 5, I'll show you the generic kit that they make for independent shops. Once again, this is a specific kit for General Motors, as General Motors specific software and help file and so on. And I'm sure they're working on packages for other automobile manufacturers too. But there's a generic package out there that would work with just about anybody's vehicle as long as it had the 16-pin data link connector and supported the J2534 communication interface. All right, so let's open up the software here. Well, we can't yet. We have to connect it to the vehicle. So I'm going to take this over to the vehicle, and we will connect it up and show you the software and then do some diagnostics on the vehicle. Okay, we're over to the 2013 Camaro ZL1 that we have here to experiment on. I've installed some vibration problems on this car, and we are going to use the GM version of the PicoScope software to diagnose the vibration problems on this car. And so, as I mentioned over at the other bench, we've got a USB connection that hooks the PicoScope oscilloscope box to the laptop, and then the scope lead cable that connects the NVH interface to the oscilloscope, and then the vibration sensor itself we've got mounted inside the car. Will you open the door? Let's look at where that sensor is. So we've got it mounted on the seat frame right in front of the seat. Looks like we're not going to be able to see it very well, but anyway, it's right there in front of the seat on the steel seat frame. Go ahead and shut the door there. And we've got a good solid magnetic mount for the sensor. It just happens to be sitting in the vertical position, which is how PicoScope recommends that we connect it. And so now let's take a look at the software here on the computer. Okay, so I've just got a shortcut for the software right down here. I'm going to click on that. It's just labeled GM NVH. Brings up this screen here, and over here on the left hand side we have an option that reads NVH, or we have an option that reads balancing. We're not going to do balancing in this episode. We'll do another one on balancing. So we're just going to go with NVH. So I'll click on that. And up pops the PicoScope NVH Analyzer Setup Wizard. And we're going to select Start a New Test. We could also load a saved test if we had saved any previous diagnostic processes. And we could skip the wizard and just use the last settings. So if we'd already punched in this vehicle, it remembers the last vehicle, and we could go there to just instantly start again on the same car. But we're going to go with Start a New Test. So when we start a new test, it brings up a window here, and it has engine RPM selection at the top here, and what it wants us to do is select one of three ways for the oscilloscope software, the PicoScope software, to determine engine RPM. One way is to use the data link connector. So right now it has selected the GM MDI or an approved J2534 device. J2534 is a Society of Automotive Engineers standard for data communication. So we're telling it to select or search the J2534 because the GM MDI supports that. We could also tell it to search for an ELM 327 interface. Now, let me zoom the camera out here just a little bit and show you. I have personally tried right on this same vehicle a couple of other interface methods besides the GM MDI. Now there's a new MDI coming out. It's the MDI2, so that the old MDI will become a little more plentiful, but it is a fairly expensive piece of equipment. I have here that I just ordered off of the internet. I can't remember. I believe it was on Amazon, but this is a ELM 327 USB data link connector interface, and I believe it was around $30. The GM MDI is a lot more expensive than that, but the GM MDI does a whole lot more than this ELM will do, but the ELM will work for the NVH diagnostic. So if you get an ELM USB interface, you can use that with the GM software, at least that I've found so far. Also, there's another company called Mongoose. This is the Mongoose Pro MFC from Drew Technologies, and it also works. Of course, both the ELM and the Mongoose, you have to install the USB drivers for them to work. But both of these I tried on this Camaro just before shooting this video, and they work just fine. What does not work, and don't get tricked into buying any of these, are the wireless interfaces that say ELM 327 on them. There's a Bluetooth interface one, there's a Wi-Fi interfaced one, and then there's a small newer version 2.1 Bluetooth interface. None of these work with the current PicoScope software. Who knows? They may in the future. That way there's no wire between the data link connector and the laptop while you're doing diagnosis, but none of these work at the moment. So this is the GM software. We're supposed to use the GM MDI with it, which if you're at a dealership, you have at least one. But if you're doing NVH diagnosis and you don't have another MDI, rather than spending all that extra money on one, just get one of these less expensive ones. The Mongoose ones are around $400 or $500, somewhere in that range. And there's different mongoose versions for different vehicle manufacturers that do more than just your generic J2534 communication. Okay, the other option is channel A. It says square wave tachometer. Some European cars, so if you're doing this in Europe, I forget which pin it is, maybe it's pin 1 of the data link connector over there with the diesel engines is just simply a tachometer signal. And so you could pick it up there off of that. Or there's another option here that says reads static, and that's static RPM, and that's to where you don't have to have an interface with the data link connector. You just simply punch in the engine RPM that the engine is at while the vibration is occurring, and it'll base its calculations on that. So we're going to hit next. It's going to try to connect with the MDI, and the MDI will try to connect with the vehicle. And let me zoom in so you can see what it says here. It says the MDI is connected. It's pulled the VIN number up for this particular vehicle, so I'm going to hit next. Now we have to tell it what type of engine. Is it a V-type engine or an inline engine, and how many cylinders? We need to know that because there are different types of normal vibrations for different configurations of engines. And we need to determine if it's a normal vibration, then we have a powertrain mount problem, a motor mount, trans mount, exhaust mount that's transferring the vibration into the passenger compartment. If it's a non-normal vibration, then we try to fix the source of the vibration rather than fix the transfer path. So we'll hit next to continue. We want to know, is it rear-wheel drive, front-wheel drive, all-wheel drive, or four-wheel drive? We're going to go with rear-wheel drive on this Camaro. We need to know the rear differential gear ratio. Now in a General Motors vehicle, that's the RPO code, the regular production option code. Typically on the Camaro it would begin with the letter G, but it could be an H, it could be an F also. But there's a 3-digit code that you look up on the car, on an RPO sticker, and then you compare that code to GM service information to get the gear ratio. And you enter that in here. This car is a 323. Luckily, it was printed right on a sticker on the bottom of the rear differential, so I lucked out on this one. So I'll hit next. Then they want us to enter the tire sizes. This car has 285 35 R20. Actually, they're ZR20s, but it won't let you enter the Z. It just wants the R. And we're going to use the same value for both tires. So we'll hit next to continue. We want to know where the sensor is located. We have the passenger compartment or the engine compartment as an option, and which sensor. It defaults to the TA183 sensor that comes with the PicoScope kit, but there are other sensors available also. So we'll hit next, and it tells us to connect the accelerometer to channel B of the oscilloscope. Tap on the sensor to verify the signal. We just kind of wiggle the sensor a little bit there, and as he bumped it, the spike went over. We're getting signal quality here. A signal. If there was no signal at all, then it's not connected. Maybe you've got a dead battery in the NVH interface box. So we'll hit next. It tells us to attach the accelerometer in the upright position on the driver's seat rail. That's the best place for the sensor in my 20 years of vibration diagnosis experience. The thing you're trying to do is duplicate what the customer or the driver of the vehicle is complaining of, and it needs to be there in the passenger compartment. I have never found a vehicle that I could not find the source of the vibration with the sensor in the right there on the driver's seat rail. The sensor location will affect the amplitude level, which is how hard it's shaking, and this software will measure the amplitude level, but the frequency will be the same, and it's really the frequency that we're matching to the different rotating components. So we will hit next. It says you have completed the setup process and now can perform NVH tests. Click here for help on diagnosing the NVH faults. If you need some help, you click on that and it opens up the Vibrate software help file for diagnostics, and it has all kinds of great step-by-step information in there on narrowing down the actual source of the vibration and repairing it. But you can't even do that yet until you figure out which group of rotating parts on the car is responsible for the vibration. And typically there are three groups. You've got things that rotate the same speed as the engine, or rotate relative to engine speed. So those are called engine speed related vibrations. There are components that spin the same speed as the tire and wheel assembly, so all of those. And then you have things that spin the same speed as the propeller shaft. So those are the three main groups of parts that can cause a vibration on a vehicle. There are electric motor driven components too, but those are a little easier to diagnose since you can turn those things on and off. Okay, so right now we're looking at the screen, nothing's going on. We're going to hit start recording down here. We can click it with the mouse, or we can just hit the space bar to start recording. And we have several different options to display what the PicoScope software thinks is the source of the vibration on the vehicle. Right now we're looking at bar graph. And between bar graph and frequency, those two I think are the most helpful out of these three, and we're going to look at both of them. So let's go ahead and start the engine and just let it idle. As you can see here on the screen, the blue line represents engine RPM, the black line represents the vibrations that the sensor is picking up. Now we're just in park with the engine idling. This is a brand new car, so we would hope there would be no abnormal vibrations. Now let's look at the bar graph. There's barely anything going on up here. We have an E1, which is first order engine vibration, which means there's 1 shake per revolution of the crankshaft. We also have an E4, which is 4 shakes per revolution of the crankshaft. Now E4 is one of those normal vibrations because it's an 8-cylinder engine, 4 cylinders fire per revolution of the crankshaft. So you've got the thrust of the compression stroke pushing down on the crankshaft, and you get 4 pulsations per revolution, but it should be really low in amplitude, and this one is. What they tell us in the GM specifications is we want to keep the vibration amplitude below 10 millig's, and the G over here, the G is a force of gravity. So we've got a tiny bit of E4 showing up, and that's because it's a normal vibration, but it's an extremely small amount of amplitude, well within specification. If this were a diesel, it would be a little higher because the diesels have higher compression ratios and their pulsations are a little more severe. But we also have listed across the screen, we have T1, T2, T3. Those are first order, second order, and third order tire speed related vibrations. Right now the vehicle is stopped, so the tires aren't even rotating. Over here we have P1 and P2. Those are propeller shaft first order and second order vibrations. I'm going to add a vibration. There's a box here to add a vibration. I'm going to add third order propeller shaft vibration also, because this has a unique propeller shaft with the flexible rubber joint rather than the universal joint. But it has 3 flexings as it rotates. Okay, so let's see if we can pick up a vibration that I've created on this car. So go ahead and put it in drive. You'll have to turn off the traction control. There's a little button in front of the shifter. Did you find that? Is it off? Okay. So go ahead and let go of the brake. And, oh, let go of the park brake off also. There we go. Okay, so now, good. So now we've got, take it up to like 30 miles an hour. Now we're doing this on the hoist. Obviously, you'd want to do this on the, you don't want to do this on the hoist. You want to go out on a road test to do this. But he's going to try to maintain approximately 30 miles an hour. And we'll take a look at what the bar graph is showing us. Notice our T1 line, T1 graph over here is going up a little bit. If it won't stay steady, downshift the transmission into like second gear or third gear. And try 30. If that doesn't hold steady, then go to 40. Sometimes you've got to shift gears to get things working like they should. As far as we don't want the transmission upshifting and downshifting like crazy while you're driving. Now notice right here on the screen we've got a T1 line at 29 millig's. I told you anything higher than 10 is got a problem. And over here we've got a P1 at 16. Okay, take it up to like 50 miles an hour now. So we've still got our tire at 16. We have our P1 at 12, 13. Notice everything else is pretty low, so we can ignore those. So if we go to frequency, this shows us the amplitude level going up and down, and the frequency goes across the x-axis here at the bottom of the screen. And we've got the P1 amplitude, which is how hard it's shaking, right here, and the T1. Okay, go ahead and let off on the gas. Just let it come down to an idle. But put the transmission in neutral. Okay, step on the brake. Put it in park. Okay, now, will you hop out and let's move the sensor up to the engine itself. I want to show you what happens with the... So, come on out, take the sensor with you. You can maybe just stick it to the hoist and go around, or find some place on the engine itself that you can attach that magnet to. Okay, so the screen goes crazy while he's trying to attach the magnet. Just a bolt or something. There we go. Perfect. Okay, so now looking at the... Let me get the reflection out of the way here. Looking at the screen, we're picking up an E4 vibration, but that's on the engine side of the motor mount. And the engine side of the motor mount is supposed to have the E4. It's a normal vibration. If we go to the bar graph, the E4 should be fairly high. Notice it's right there bouncing off of 10, 11, jumping around millig's. So that's a normal vibration to have on the engine. Now, can I get you to move the sensor just over to the fender, the inner fender or the radiator support, so that we're off the engine now? And let's watch that go away. And what you can do with the sensor is check your motor mounts to see if they're working like they should. Check your transmission mount, your body mounts, exhaust mounts. There, now he's got it on the radiator support. Notice we're clear down to 4, 3, 2, bounce around a little bit, millig's. Sorry about the reflection there. And it appears the engine mounts are doing what they are supposed to do. So this is a fantastic vibration analyzer package. We're picking up the engine RPM off of the data link connector through the J2534 interface. We have a NVH sensor that we can move around with a very long set of cords that we can move just about anywhere on the vehicle. And the frequency over here with the amplitude level, we've got an E4 over here, the E1. We've got a spike right here, but notice that doesn't have anything labeled with it. And it could be, and most likely is, a vibration that we ignore. It might, actually it looks like it's double of the E4. It's probably the E8. But sometimes all of those vibration analyzers, and I haven't investigated this one yet, will give you frequencies that don't correspond to any rotating parts on the vehicle. And in that case, I would suggest that you just ignore them and go with what the number one vibration is that is identified as one of the rotating parts on the vehicle. Now there's add vibration over here that I mentioned, where we added the third or fourth order. No, what did we add? We added third order prop shaft. Let me put eighth order engine in there. See, it's not eighth order engine because eighth order engine would be over here. So it's just something we're going to ignore, and that's fairly common. Whoops, turn that off, for vibration diagnosis. Okay, well, this has been a demonstration of the General Motors PicoScope NVH kit and how to use it to diagnose which group of rotating parts on the car. Will you go ahead and turn the key, or turn the engine off, but then turn the key back on? So thank you. That's all I need. The thing you do now, which is the same as any other vibration analyzer, is once you've got it narrowed down to first, second, third order tire, and if you recall, order means how many shakes per revolution that device is creating. So first order is 1 shake per revolution. So T1 is 1 shake per revolution of the tire. T2 is 2 shakes per revolution of the tire. T3 is 3 shakes per revolution of the tire. We've got the E1 and the E4. We've got those are engine first and fourth order vibrations. We've got P1, 2, and 3. Those are propeller shaft vibrations, first, second, and third order. And on this vehicle, I put some extra washers on the propeller shaft bolt at the pinion flange to make it out of balance. On one of the tires, I put some extra adhesive weights to cause a vibration. And on the hoist, where this is a limited slip differential, both rear tires turn the same speed. And so it worked okay on the hoist to do it this way. But you guys need to remember that on a vehicle with an open differential, or even the Eaton G80 locker, it will act as an open differential, and those tires can turn at different speeds on the hoist. And you should avoid using the hoist because it can give you some misleading numbers that you would never see on an actual road test. All right, now the big question is once you've narrowed down which group of rotating parts is the problem, what do you do about it? Well, in this software, you can bring the mouse over and click on P1 right here. And P1, a little window pops up and it reads, first order propeller shaft or prop shaft speed related vibrations can cause one shake or disturbance for each revolution of the prop shaft. On standard four-wheel drive or all-wheel drive vehicles, don't forget that the front prop shaft can also cause this same type of vibration. Shift the vehicle in and out of four-wheel drive in an attempt to verify and isolate the concern. Obviously that doesn't apply to this Camaro, but click here for more information. And when you click here for more information, it brings up the Vibrate software help file for first order prop shaft vibrations. And it tells you what those vibrations are typically caused by. And it's caused by a component that's out of round, that's rotating the same speed as the prop shaft, or a component that is out of balance. And so it has step-by-step procedures for you to diagnose this. This refers you to the GM service information to measure propeller shaft runout, and then also to refer to the GM service information for checking imbalance. And this software provides tools to do a strobe balance on a propeller shaft. Okay, so if it's a T1 vibration like we had, we'll click on T1, and it tells us first order tire speed related vibrations are caused one shake or disturbance for each revolution of the tire. Click here for more information. Up comes the Vibrate software help file for first order tire speed related vibrations, and it gives you a number of things to check. And in this version of the file, help file, you are to go back to the GM service information and follow the step-by-step procedures in the GM service information for measuring a tire that's out of round, a tire that's out of balance, a brake drum or rotor that might be out of balance, an axle flange or hub that's out of round, wheel stud circle run out, stiff spots in the sidewall. You might have a radial force or lateral force variation problem, or even axle problems. And so those are the things that you check that can cause this type of vibration. So with this software, once again, and the NVH Analyzer and the interface with the data link connector, we can narrow down the group of rotating parts on the vehicle, and then we can look at the help file for step-by-step procedures of where to go and how to diagnose each individual thing. And those are listed in most likely cause to least likely cause also. So this is I believe, a very impressive tool. As I said before, it can work on non-GM vehicles, but you will need the non-GM software that you can download from PicoScope's diagnostic website for free, and then it'll work on any vehicle. All right. Well, that wraps it up for this episode. Our next episode, I will show you the generic version of this software and the generic kit for independent shops and how to use that. Have a good day.